In Chapter 11, we're going to step away from algebra for a while and start looking at statistics. Section 1 is a lot of vocabulary around statistics, so I want you to be able to use the vocabulary around statistical questions and variables. So here's a piece of information. It's some information about the prom ticket prices at different schools. And I want you to think about 3 questions or observations that you have as you look at this data. Statistics is a way of analyzing information and turning it into an answer to a statistical question. A statistical question you could ask about these prom tickets is, what is the average cost of a prom ticket? What is the cost that most schools charge for a prom ticket? Would be a slightly different question. What is the highest price that a school is charging for a prom ticket? Would be another statistical kind of question. So a statistical question, piece of vocabulary, is a question that can be answered by collecting data. And one of the big jobs of statistics is summarizing that data in a way that makes sense. So that's what this chapter will be about. So if someone asks, when is your birthday? That is not a statistical question. That's a question that has one answer. You are the only person being asked this question. But if someone asks you, in what month are the most people born? That's a kind of question that you could answer with statistics. You'd have to do a sample and ask a lot of people the question, when is your birthday? But asking just one person that question is not a statistical question. Here are 2 different graphs. I want you to think about which graph answers a statistical question. The first graph shows students' ages in years and how far they travel to school. And so the second graph shows how long you've been traveling and how far you have traveled, if you're traveling 20 miles per hour. The first graph is answering a statistical question, which is how far are children of different ages traveling to school? And the only way to get that information is to find out by sampling a bunch of students and finding out how far they travel to school. The second question doesn't answer a statistical question, or the second graph doesn't, because it's just, there's only one answer. If I'm going 20 miles per hour and I travel a certain number of miles, then that's how many minutes I've traveled. I just have a couple more examples of things that might be statistical questions. How many lithographs did M.C. Escher create? M.C. Escher is a mathematical artist who does a lot with tessellations. This is not a statistical question. You can just find out that information. It's not something that involves sampling and asking a bunch of questions. This question, which is the most popular visual art form? Is it photography, painting, sculpting, or drawing? This is a statistical question because in order to find out which one is the most popular, you'd have to ask a sample of people which type they like the best. There are 2 different types of statistical variables that you might use in answering your statistical questions. There's a quantitative type of variable. It's something that can be counted or measured, like your age or your height, your GPA. And then there are categorical variables. They're still statistical variables, but they're descriptive about either you or whatever you're sampling. So it could be eye color, your favorite class, or things like that. So here's a statistical question. We want to find out what are the favorite types of Olympic sports for a sample of people. And as the person goes around and asks, what Olympic sport is your favorite? Remember, that would just be conversational if I only just cared about one person. But since I'm asking a whole bunch of people that question, it starts being a statistical question. But this is a categorical variable because the answer to the question is not something that you can measure. You can measure how many people answer the question, but if I say gymnastics, that's not something that you can measure. What type of variable would this be? How many apps do teenagers have on their phones? Person goes around and asks a bunch of teenagers how many apps are on their phones. And that is a quantitative type of variable because you just count how many apps are on the teenager's phone. Here are two more I'd like you to try and think about. What type of variable does each one represent? What breed of dog is most likely to be adopted from an animal shelter? That is categorical data because it's still answering a statistical question, but it's categorical because the answer as I study each dog is not something I can measure. What is the average number of students per activity participating in after-school activities at EHS? This is a quantitative question because I can count how many students are in an activity. Here's a graph that represents a variable type, and this is a categorical data type because blue, red, green, yellow, orange, and purple are categories. I can count how many pieces of fruit fit in each category, but the category itself is categorical. Okay, more vocabulary. A population is going to be all members of the group that you are studying. A sample is a subset of that group. So one of the big things in statistics is finding a way to get a sample that accurately represents the population. The sample is easier to work with. I don't have to ask every single person the question. I can ask just a sample. But if the sample doesn't accurately represent the population, then it's not very useful to me. So I have to find a way to make my sample be a good representation of the population. Okay, so in this question, I want you to think about which one is the population and which one is the sample. A school newspaper randomly selects 30 students from each grade level to participate in a survey to determine the opinions of the students at the school. The population is all the students at the school. And the sample are the 30 students from each grade level. The randomly selected students from each grade level means that they are attempting to make sure that that sample is going to represent the whole population. A poll randomly chose eligible voters in the state of Illinois to ask who they would vote for in the governor's race. The population is the voters in Illinois. I don't care about any other state. I just care about the voters in Illinois, since only Illinois voters can vote for governor of that state. And the sample is the randomly chosen voters. A population or a sample does not have to be people. I want to emphasize that. A city worker collects 5 vials of water from each of 10 randomly selected locations all over the city to test for levels of bacteria in the city water supply. In this case, the population is the water supply of the entire city. And the sample that we're using to think about that city water supply is just 5 vials of water. Going along with parameter and with sample and population, a parameter is going to be a measure that describes the whole population. So if I've done my sampling correctly, I can extrapolate from that sampling and make a judgment about the entire population, and that would be a parameter for the whole population. The statistic is the piece of information that I got from my sample. That's going to be a measure that describes just my sample. So a high school has 3 lunch periods, in a randomly selected lunch period, 24% of students brought their lunch from home. Since this is just about a sample of the population, the kids who have that lunch period, this is a statistic. It's not about the whole school. At the end of its first year of business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales and number of tickets sold to calculate the mean amount spent at concessions by a moviegoer was $8.14. This is a parameter because the theater used all of the concession sales and all of the ticket sales to get that information. A snack company produces bags of almonds so that each bag contains about the same number of almonds. The bags are filled with an average of 27 almonds. Carter gave each of his friends a bag of almonds for a snack after school. Their 5 bags contained an average of 31 almonds each. So the parameter is the 31 almonds because that was from, sorry, I lied. I said that wrong. The parameter is the 27 almonds because that's in the entire population. The average is 27. The statistic is the 31 almonds that the friends found in their bags because those came from a sample. All right, so that's the summary of statistic language that we're using. We're going to use statistic and parameter. We're going to use population and sample, and we're going to try to determine whether we have categorical or quantitative types of variables.